Hello everyone, this video is about the conversion process of a binary number into an octal number. This is nothing but a grouping of 3 bits starting from LSB. Let's work it out with an example. Consider this binary number system, I mean a binary value with decimal number. And initially we have to group the given bits, I mean given number, into pair of 3 starting from LSB. So here the binary number has 6 digits to the right and left of the decimal point. So starting from the decimal point, first group 3 bits towards left from the decimal point. So here it is, and take this number, it has 3 digits. Each of 3 bits have a positional value. Let us assume the 3 bits as B0, B1 and B2, and each will have a positional value of the form 2 power n. So for the bit 0 it will have 2 power 0 equal to 1, and for bit 1 it will be 2 power 1 equal to 2, and for bit 2 it is 2 power 2 equal to 4. Now the positional value of the bits are to be multiplied with the actual value of the bits. Here the actual value is 101. So taking this number, we are multiplying with the positional values, and the equivalent values will be, here it is 1, and here it is 2 into 0 is 0, and here it is 4 into 1 is 4. So sum of these 3 bit values, I mean 3 values, it will be 5, and this is the equivalent octal value of this pair of bits. Next, we will, to simplify this process, we will have the positional values are as 4 to 1 codes, and for the next pair of bits we can take the code as 4 to 1 code, and for here it is 0, so 1 into 0 is 0, and 1 into 2 is 2, and 1 into 4 is 4. So 4 plus 2 is 6. So we have completed the left side from the decimal point, and for the right side we can take 3 bits, and this will, we have to calculate with the 4 to 1 code, and here it is 4 into 1 will be 4, and 1 into 1 will be 1, so 4 plus 1 is 5. For the next 3 bits, it is, for 4 to 1 code we will be having 2. Hence the octal value of the given binary number is 65.52 to the base 8. Thank you.